Sound check, sound check. Hello world, my name is Stefan, aka Flashover, and today we will continue building a benchmarking library for Roslyn components. We are still on the way on completing the benchmarking types necessary in order to facilitate benchmarking of incremental C# source generators. So in today's session, we had session number 3. We'll have a look at what we accomplished last time, and we'll continue with building the incremental generator for C# actually. At a later stage, we will do the very same for Visual Basic as well. We at least want to achieve optionally enabling the invoking the benchmark with memoization, which is a specific about incremental generators, which is the main distinction between the Roslyn 3.8 source generators and the Roslyn 4.0 incremental generators. Then I would like to not only assert for the inspection phase, not only assert the source itself, but also the hint text it is written in, which is a hint for tooling to basically display the name if it was a file. Per default, the files are not written to disk. There is debugging options that you can enable actually writing the files to disk that the generator generates, but per default, they are actually not written to disk. And for the last, we will begin with building the diagnostic capabilities to, in the inspection phase, allow certain diagnostics to be expected. So jump into the code. Just had a look beforehand if all the tests are green, which they are. So it's a good starting point. Let's open up the types. So we are at C# incremental generators package, which will be the first one to publish. And the respective tests for this. So here's our tests. And here is our production code. So we have a couple of to-dos all over the place, but let's begin with these three. Memorization. So that was one of the questions in the last session. What is this memorization that incremental generators enable? If we have a look at a generator, so this is the basic implementation of a incremental generator. There is also, which has been added in Roslyn 4.0, which requires the .NET 6 SDK. With the .NET 5 SDK, we got source generators. And they have this interface. They consist of an execute method and an initialize method. So the initialize method is initializing the source generator where we can register a syntax receiver, but also register post initialization step, which basically generates source code unconditionally because we have no compilation, no pass options, no user input available. But we could, for example, generate an attribute that then for later generation phases, which is the execute, then actually is available, because different execution phases of different generators are not visible to each other. Source generators are one in a deterministic order, but this is not documented and may change. So generators cannot depend on each other, except if you initialize something in the post-initialization phase. But the drawback now is that the execute phase is run every time some code is changed. So in an IDE scenario, when the user types code, the source generator's execution phase get executed over and over again, potentially generating the same source code over and over again, which may, if this is a very big solution, a very big project, which has a lot of code for the syntax receiver or the generator in general to inspect and to generate from, may degrade the editing experience. And let's say, for example, if it takes 7 seconds to run, then with every key press, the source generator takes 7 seconds to run, which may cause a hiccups or a sluggish developing experience. So this is where the memorization of incremental generators comes in. So what we can do is only the initialization phase and then the actual execute phase, which we can do via this callback in register, where is it? Register source output. This then gets only executed if anything in the pipeline before has changed. So the same input generates the same output, the cached output actually. We can have a look at a more exciting implementation of a source generator. So here we have an incremental generator, which in the initialization phase now does this setting up the pipeline, which consists of incremental value and incremental values provider, where an incremental values provider has more containers. So this has multiple syntax nodes, and an incremental value provider holds one container. So there is, for example, now turning and values provider into a value provider changes syntax node into an immutable array of syntax nodes. So it's just one thing, one container, but it holds all of them. Another example of an incremental value provider would be, for example, the compilation provider, because there is only one compilation, not multiples. And we basically then now combine those value provider. So we have our own syntax provider, which is somewhat comparable to the syntax receiver, which gets in every syntax node for the syntactic check. And for the semantic transformation, we then get every syntax node which passes the syntactic check. And we can then, transform it, but also apply logic depending on the semantic model. And if now this syntax provider in this pipeline has the same input, generating the same output, potentially other steps don't need to run. And we combine that with the compilation. We combine it with everything that we have in this example, with the compilation, the parse options, additional texts, also analyzer config options, which may be contained or may be read from editor config or .global config files, and metadata reference provider. We combine all of these, and if they yield the same input, then the generate source, the actual execute phase, would create the same output again. So with the memorization now, the tooling may understand, okay, I basically would have had the same input for the execution phase, so I don't need to run it again because I can use the previously run result. And this now potentially saves a lot of performance. And in our discussion live that we had last time, David Venture brought out the idea of potentially enabling this memorization. And I would like to offer that. I thought about it a little bit, so let's take care of memorization. If we get to the benchmark, we could, for the initialized phase of the benchmark, we could provide that flag in here, basically enabling like use memorization, per default having it false. So to have the same behavior as with a regular iSource generator or with the 3.8 iSource generator, because these don't support it. It's an additional feature for the newer incremental generators. But then we would need to have in our invocation step, we then basically would need to have an if check. And we have this if check every time. So this would be, would need to store this somewhere and then have use memorization, have basically then an if and else check block. I would need to run this if check every time for each invocation, and in a benchmark, this is called a lot of times. So perhaps this is not the best, because I would like the invocation phase to be as pure or as clean as possible, only doing what's absolutely necessary, which is running the generator. So I thought a different approach would be to have something like a class or a type that we then subclass. We could have like a public abstract class, the invoker, or the I call it invoker for now, invoker, which basically has one public abstract void method invoke, and we could derive two variants of it, the not sure, base invoker, and what it's called the default invoker, and the memorization invoker. They both inherit from the invoker and now implement the invoke So this is no longer abstract. This is sealed. So we must implement the abstract method. And we could have here basically, invoke without memoization, and here invoke with memoization. But I'm not entirely sure if this is the best solution either, because then we have an virtual dispatch, because during runtime we know we have an invoker, but then at runtime the runtime needs to figure out, okay, which implementation is it, because that's an abstract method, and then actually call into it. And this may also be not the fastest way possible. So what I would like now to actually implement is a separate method, which I call invoke with memoization. I think I had the string here so that I don't do a typo. And now in here we would like to have, run it with the memoization in place. But first we need a test for that. So we know that with the same input, subsequent ones should be faster. So what our test could look like is we could basically measure the duration of the initial one and then see if the duration of the second one is significantly faster. So do we have a simple test that we could copy? Perhaps should I make a partial now? When this file gets too big, then I will split it up into multiple partial classes. So let's have our invoke. Actually, let's not care about the inspect phase here. And we call it invoke without memoization. And the second one is invoke with memoization. So we will measure the initial one. We can start a new stopwatch. Stopwatch, which should be in the diagnostic namespace. Diagnostics namespace. Start new. We stop it. We store the elapsed time. And then restart it. Then we invoke it again and basically do the same again. So we have now the initial elapsed and another one at second elapsed. Those are both time spans. And now I would like to say that they are quite similar. I'm not sure how we can do this. Perhaps there is something with fluent assertion, which allows something like not be close, should be close to. That sounds good. So the initial elapsed should be close, or we actually have the second elapsed should be close to the initial elapsed. What is the signature of this method? Asserts that the current time span is within the specified time from the nearby time. And nearby time is another time span, but we also pass in a precision. The expected time to be compared to the maximum amount of time which the two values may differ. Okay, not entirely sure what a reasonable time is here. So let's try. It should be relative because I guess that's heavily depending on the machine's power. Let's find out if we do time spent.0 what the test says. It says the second elapsed to be within the default of 125 microseconds, but we found 57. Not sure if I read that correctly. So we expect it to be pretty much the same. So it's like in the microsecond area. So let's say to be, let's maybe actually add a bit of a source code. Let's create an object initializer. Let's add some source. Let's create a new string builder. Let's give the generator something to do. And we for each, or have a for loop of 1,000 elements, and we add append line let's start with a namespace. We'll copy this from here. Let's call this namespace testing. We use a blocks, a file scope namespace here, and we append a lot of classes. So let's do a public let's do a struct, public struct my struct, and let's append the integer to it, and yeah, make it a valid class. So we need 2 in order to escape. Okay. The behavior. Okay, yeah, we really don't care about the format provider. It's a test here, so let's suppress that warning. But let's do this on the entire class. I'll perhaps move this later on to an global config testing. Oops. To do move to global config. Or is it analyzer config? Not sure what the name is. And let's toString to have this as an input string. Okay. So we have a lot of, we don't need these. Text, we create 1,000 structs. Let's perhaps also give it a property, public int my property get init. This should be a valid struct with one member. And yeah, so let's see now that the generator actually has something to analyze, what the result is now. It's to be within the default from 3 milliseconds, and so what's a reasonable amount? So it seems to be quite in the microsecond area. Can we have like a, like a tenth. Can we say initial elapsed divided by 10? So if we are within a tenth of, or half, I hope I used this correctly. Let's have a look at the documentation. Time span, dates and times. Okay, we could say it differs quite a bit. It shouldn't. Why is the second second one so much faster? So the first one is 12. The second one is significantly less. That does bother me. It's 1 millisecond. This one is... So hold on. Second elapsed. There we go. Initial elapsed is 126 milliseconds, and the second one is significantly faster with just 1 millisecond. This shouldn't be. I expected it to be the same. Does it actually do use some memorization? Or do I need to... What's actually the difference between one generators and update compilation? Let's have a look at the Roslyn source. So both of them do the one generator's core. But the second one also exposes the diagnostics and outputs the output compilation. So they should be quite the same actually, other than exposing the output compilation and diagnostics too. So why is this so much faster? Since I expected to, if I then actually assign the driver that we return from here, I expected this to be significantly faster. But this one, since we discard the updated driver, shouldn't be. But let's have a look at what if we've applied the same test. For the with memorization test where we... I thought this, maybe I misunderstood there something. Oops. Can I stop? Yes, I can stop. I need to call invoke with memorization for both. Okay, so this one passes now, interestingly. Because it was significantly faster, yes. What's that like? That's like the initial elapsed is 144 milliseconds, and the second elapsed is so I didn't change anything. I just called invoke with memorization. I should no, assigning the driver. Yes, this should be the change. So the initial elapsed is 129 milliseconds, and the second one is 0.3 milliseconds. So this is significantly faster. Perhaps in order to make this test reasonable, perhaps I need to do some, no, doesn't really make sense. Some warm up perhaps? What if I do a regular invoke, which I do not benchmark for both of them. Also not benchmark, but measure, and then measure 2 invocations. So the with memorization fails because be close to, not sure if I read this correct, the second to be within, yeah, so that's half, but it was found. So is this like the maximum? Be close to precision. Perhaps I don't really understand the precision. The maximum amount of time which the two values may differ. So for this one, I actually kind of expect it to be significantly faster, unless I do this division here all wrong. So if I divide the initial elapsed, which are 1.2 milliseconds, if I divide it by 10, it should be 1 millisecond. Ooh, the result is a double, not a time span. How does this, is there a implicit conversion? There is an implicit conversion. No, that's the operator. There is no implicit. How does this work? Well, I should use the divide. Yes. Divide it by 10. And up here, divide it by 2. I think I'm doing it all wrong, since actually the second one should not be close. The first one, they should be close to each other in a rather small time frame. Let's say 10 is actually what I should expect, that both of them should be rather close. They may differ by 10%, if I write this correctly. But the second one should be significantly faster, so it should not be close to something which is even half, or without the precision, yeah. So it should be at least double the speed. I hope now I've formulated it correctly. Okay, seems to be, but let me check that. If we have an elapsed time of 1 millisecond and divide it by 10, it should be 1/10 of a millisecond. Okay, yeah, that sounds reasonable. And yeah, I think if I debug, or do we have some flakiness? Okay, that's 1 millisecond, 3 microseconds. Divided by 10. But found. The second one. I'm still not sure if I use it correctly. What else do we have? We have a date be less than. Oh, so there is a date time. It's actually a date time. Time spans. There we go. Similar to date time assertions, be close to and not close to are also available for time spans. So we have a time span, and we say it should be within 10 ticks, I believe. Okay, this is green. Let's see if it fails if I call here the regular invoke, and up here the invoke with memoization. Both of them should fail with a error message I hope to understand. The second elapsed should have been within 140 microseconds from so it was 1 millisecond, but it was not. So it was significantly faster, 1 millisecond and 400. So basically 1 millisecond faster, if I read that correctly. And this one, it should have been within, but it was slower than expected. But that's all right because I expected to use memoization, which should be faster. So I believe this test is all right. Perhaps I can tweak the precision here later on, but I guess that does it for now. Let's run it again just to be sure there is no flakiness, which maybe if we have timing. I definitely need to run this on a different machine to see this on a slower machine or faster machine. What if I remove this initial invocation? Was this just a error that I made? Now they fail without memoization, because now it's like actually somewhat it's just an invocation which doesn't cache. Maybe there is some, maybe that because is it because of the initialize, because the initialize is invoked once and then not again from the generator. I mean, let's see what gets invoked. So we have the initialize here because we do quite some combination. This may take some time in the actual execute phase. Let's run this benchmark and see where we land. We have to initialize once while we are invoking for the first time. Now we're executing while invoking. And we are, okay, no, we're initializing again. So this is as expected. And executing again. But, yeah, and if we have both, but with the memorization, let's see where we end up now. Did I remove the breakpoints? Yes, I did. I did not mean to. Execute breakpoint, yes. So we are in the initial invocation. We won the initialization, now the execution, and with memorization, now we just run it again for the first time. And then invoke with memorization the second time doesn't even go anywhere. So that's cool. Perhaps I could to have a more, perhaps we don't do it with timing, but with actual invocation of the methods that we expect. This may be then timing independent and more precise. So let's have a separate generator. The, how do we call it? Like a counting invocation incremental generator, which should be an incremental generator. Can we like inspect this? Is this only invocated? It should be only like once, so I call it an, I guess this would be a spy, so I call it the spying, if this is English. Die Bespitzelung, yeah, die Spionage, yes, that's indeed the word I was looking for. We have a spying incremental generator. Let's rename the file as well. Rename file to spying incremental generator.cs. And this one counts. Initializations. We have a private set. Initializations. And we have executions, where we context dot register source output. Should we, well, we are having, let's at least create a syntax provider. Or should we just reuse the existing? Let's reuse the existing one. I get rid of the spying one again and just add it to the existing test generator, where we have those two properties, both with private sets. The initializations and the executions, where we increment the initializations and the executions. Yeah. And in here, can we even do that? Because I don't get the instance of. Of this C# incremental benchmark, we could make this generator, we could expose it. Let's make an What is the flow? I think it is first the, or what's the order? I think the properties come after the constructor. Style cop order ring rules. Oh, that's not good. Uh-oh. GitHub, yes. Order ring rules. This one looks good. We first have, within the class, we have first the fields, then the constructors, finalizers, delegates, events, enum, interfaces, properties, and then we have the methods. Okay. So we have here where we expose the generator, but let's make that one internal. So not for the general consumption. And invoke without memorization, we can now say, okay, after, let's assure that benchmark dot generator dot initializations should be 0. Both initializations and executions after we invoke. Let's get rid of the time spans. After we invoke, we want them to be 1, and after we invoke just again, we want both to be 2. Let's see if that works. It looks green. And let's do the very same for the test below, where we I think we can, let's do it in one test. And then after we've invoked it, and we invoke it with memorization, since we haven't memorized yet, we expect 3. But after doing it again, we still expect it to be 3. So it increases. This one doesn't change the driver. No, this changes the driver field, so every subsequent now should still be 3. 0, 1, 2, 3. Okay, let's see if this passes. And I totally missed that I have gained a new follower. X cubed, thank you very much for joining. Yes, so it's green, and now we are timing independent. I do like this way better. Okay, so first one down for today, or at least the planned one. So on to the next one, the hint text. I also want to assert the hint text. Speaking, when we have, like in this test here, this is the source that we expect, but I also want to assert the hint text, which may not be. Should we do it with a value tuple? Perhaps we do it with a value tuple, but I have no idea if this then works in Visual Basic as well. So this may totally change. So we have 2 strings, we have the, let's actually check out the generator. How did I use the correct naming? When we add a source, yeah, we first have the hint text, the hint name, and then the source. So let's call these the very same. And this entire thing maybe now, but yeah, let's do it like this. And we have the hint name and the source. Then we have source.source. It's perhaps weird. Should we call it source text? Let's stick with it. We can rename it later. And now, of course, nothing compiles anymore, because we need to add the hint text as well. And I'm not sure what we expect, so I just say to do here. Let's do the same here. To do and the actual source. To do and the actual source. Yes. Let's run the test. I would not expect something to fail, but yeah, okay, now we have source.source. Oh, it's nullable. It's nullable. So if source, let's do it like this, then it is more obvious, has value, then we get the value.source. Okay. And nothing fails, because we also want to inspect the hint text. How can we do that? We have a generate sources here, and each generated source result has a hint name here and the source text. So we could also, perhaps I copy this method and made it, let me put this to a horizontal tab below. And let's accept here the actual is a generated source. And the expected is, can I create like my generated source, syntax tree, source text, hint name. Don't really have a syntax tree, but let's use the same struct here, the value struct. We say string and we, from the actual, okay, we need to get the source twice. So let's say, don't know, let's get this one, source text.toString. This is how we get the source. Which we then expect with the expected source. Okay. This is a string. And we pass in the expected.source and our actual source. Yes. But we also want to assert the hint name. So if from the actual dot hint name, does not equal the expected hint name, and use ordinal string comparison, then we throw, and we say expected and actual hint name differ. Where we have the, we don't diff actually. Let's inline this message, and the actual, I think we pass in the actual here first, the actual, the expected. So the expected hint name is source expected.hint name, but the actual is actual.hint name. Okay. Now this should result in a failing test if I would fix this compiler error. So we have the actual, yes, so inspected source is now the, this is no longer string, this is now a generated source result. And I thought this was compiling, but it doesn't, because I pass in the entire value, this value struct. And this still does not work because semicolon expected. Excellent. And this passes. It shouldn't. I don't expect it to pass because I made the very same mistake that I did last time. I didn't set, because exclamation point. If it does not equal, then it's bad. And free tests fail because it says expected and actual hint name differ. Down here, we expected to do, but it actual was this name. So let's grab this name and put it where we expect it to be. So in the tests, I have to do as a string some places. Let's see, replace that. Let's put this into a const perhaps. It's a longer string. Private const string default hint name. Where we name of, no, type of. Type of is not, name of is constant, type of is not. Okay, so let's make it read only. And we use this default hint name here and at the other places. This should pass. It does. And okay, we have here another to do when we expect more than one sources. Enable testing more than one sources. Okay, so that's basically step number 2. On to step number 3. But perhaps let's do the multiple sources before we go into the world of diagnostics. So what we see here, we have a source, but I also want to have a sources when we have more than one expected source. And let's make this a collection of these value tuples consisting of the hint name and the actual source. Actually, I can write new, can I? Yes. target type new expression. Since C#9 available, yeah. So it knows, okay, collect exactly this type what we have here is then basically inferred there. Similar to var, but in the other direction. And now I have the feeling I already have a multiple input sources. Yeah, that's multiple input sources. But how do we expect multiple output sources? Let's jump to the test generator. What's like a nice switch that we can use to produce more than just one output here? Perhaps let's use additional text. We could combine it with additional texts because there's also a to do here with additional texts. Let's just, as a comment, print out the additional texts in a file. Yeah. So we actually do 2 new features. Shouldn't be all too hard actually. So we iterate through all the additional texts and basically let's have a separate string builder for these. Well, let's do it at the end. Let's do this at the end. After that one, so let's reuse this. We can, because I need to put a comment. So actually I need to, yeah, let's reuse that. So we have our source text and we clear it. So we can reuse this one source string builder. And let's append an opening comment /star, and let's append a closing comment // and in the middle we put out the additional text. How do we get that? Additional text has a path. We can use the path as a for the int name. So we will produce another file with a context.add_source. We use the additional text.path as a hint name. And we have a method to get the text. This is synchronous but allows for cancellation. We don't have a token here, so let's pass cancellation token.none, and we get the text of it. So we need this as a string. This is a source text, which may be null. So if it is null, let's print. So let's say question mark dot. We use the null conditional operator. And to get the text, I believe, do we just toString? I believe we just toString, yeah. Dot toString. But if it is null, then we say should we throw? No. Perhaps, well, this is our test generator, so in here let's throw new invalid operation exception. The additional text path additional text with name of additional text or path was null. Can we also name of this? Name of null, do keywords work? No, keywords don't work, only types work. No. We don't expect this to happen. So that should be fine. Okay. And we then toString that. And we have additional sources. But now we want to, now actually tests should fail already because we expect only a single output source to be generated. But now we have multiple. Oh no, we don't have multiple yet because we have no additional texts just yet. So we also need to enable additional texts. Which basically is, I guess, another string collection. So we can do so we have here additional sources. Let's create another. Actually, I can use target type new expression here as well. We have another string value type, value tuple. And the first one is the path. The second one is the text, the additional text. And we call this additional texts. Oops. For the additional texts, where do we pass them? They're not part of the compilation, they should be part of the generator. So when we create the generator driver, yeah, here we have the additional texts. But they need to derive from additional text. So let's see what types are available. I hit F1, which opens a browser window with the help. And we see there is no public implementation of this. So we need our own. Hello, Daytime. Thank you very much for following. I really appreciate it. Let's have our own. In what namespace would this fit? I also put it in benchmarking so that the user has only one type to. No, actually, I could make this internal. So let's put this in. Where is additional text? It's just in code analysis. Yeah, I make a namespace text. Oops. Let's call it one text. And let's have here a additional text, but how do we call this? What would be a good name? Benchmarking additional text. Yeah. Benchmark. No. Ad hoc. Perhaps ad hoc additional text. Let's go with that for now. It derives from additional text. We make this one internal, don't want to expose it. And this one needs to implement, I guess, the path and the get text method. Yeah. So for that case, we can make a constructor that now receives this enum, not enum, but this value tuple. We call it text. And basically have two properties. Let's make it two fields. Private, read only. We have the path. Actually, we do have the path already. So but this is a property. So let's make that property read only. and set it. Path is text.path. And since getText may return a nullable source text, we perhaps also want to make this one nullable. Then we have a nullable private text field. I think we should be able to, can we control dot this? Almost. So we have text equals text dot text. Perhaps not the best naming, but this does not, what I'm doing wrong. Can I basically convert from string to perhaps some compilation error? Let's see. And then we just return here. Now we need to return source text. But what's source text? That has quite a lot of properties. What's this abstract? So maybe there is a public consumable type. I'm again hitting F1, going to the browser and see if there are no implementations. So we also need a source text. So let's also call this ad hoc source text. Ad hoc source text derives from source text. Let's see what members this has. Make it sealed, and we need to implement quite a lot. We have a position. Okay, let's go with not implemented for most of them, and we just see which ones we really need for the generator to work. But what am I doing wrong here? So here then we just return new source text ad hoc, and let's see where this goes. What am I doing wrong? So it's not, since it's a value tuple, it's not nullable. Can I basically convert type string, but text is yes, I need to say this. Yeah, this is why I have the same name. That's bad. Let's call this additional text. Okay. Cool. Now let's see how we can integrate it. So we have here the additional text currently set to null, but we want to, for every additional texts in this context, select. This can be static, where we say for each additional text, we return a new ad hoc additional text, the type we just created, and pass in this additional text value tuple. And then we put them to the generator. So now the generator should be using them. Where's our test where we, let's do a breakpoint if we actually have this filled correctly. Do we have a test with additional sources? Let's add it to this text, to this test. Let's say we have source and we have sources. Additional text equals to, and we add, since you have a collection already, we add, what's it called, path, call it path1.txt with some text, additional text 1. Let's create a second one. And a third one as well. So we have additional text 2 and additional text 3. And for each of the additional texts, we now expect additional sources to be generated. Let's say sources. This is a collection, and we have 1, we have 2, we have 3, we have 4. And what we basically have is these. I will copy them down here. And what this generator does is basically, yeah, we have here the texts that, so they will get the same hint name. But since it's sources, we actually create sources. So let's add the .g.cs to it. Or let's get rid of the text and we change it to .g.cs. Yes. So this is what the generator does. And we put this into a comment. So we have / for the additional texts that we just put out. Okay. Now we should have a failing test, not yet, because we still need to inspect this actually. Where we can say, okay, if we have a source, we check this one. What if we have both? So let's concat it. Let's say here are our sources. And I think I created the singleton method that we call to return basically an enumerable so that we can combine it with links. So a singleton of, but only if it has a value. Can I do like this and say if this element is not null? But if it is null, we don't. So we create a singleton and concat it with the additional texts, which is context.sources. And perhaps should we array it? No. Then we have our sources. We know for each these sources. Oops. I want to use the previous name we had. No. Sources where we have each source. This should be the value tuple of string. Yes. And the value tuple of string. This could be null, couldn't it? Because it may be null. It's a nullable value. Okay. So this may be null. And dot select source is not null. Everything which is null, let's ignore these. I'll have a look at this later. Okay, and for each source, we now basically do what we do here. But we don't say, yeah, let's turn this into a for loop. We can't. We have sources.length count. Okay, we need to let's convert this into an array. Otherwise we would iterate through it, enumerate it multiple times. Now we have an array, so this has a length. Oh, yeah, I should type it as an array. So this is a length. And we get each source, which is at sources index I, and the equivalent generated source at index I. And then we inspect each and every one of them, where we pass in the source. And this fails because hint name source. This is nullable, so we need to say value here. Yeah, maybe now. Should we just, if it is null, do we just ignore it or do we throw? Is that a viable value? Well, we have the warning. Let's fix it later. Now we should actually have a failing test, or at least one. And we actually get a CS 8785. I'm not sure what this one is, so perhaps let's improve the output of this. So the actual diagnostic get message. It will not contribute. The generator crashes actually. Let's debug this test so that we actually get a break at this first chance exception, if that's the correct name. Oh yes, because I have a lot of not implemented exception. So when we do get the text, we return a new ad hoc source text, but this one is not implemented. Okay, all right. So we do need to implement the length here. So we should pass in the source. It's an ad hoc source text. So let's say string source. We will assign that one to a private field. Yes, the length will be source.length. All right. What's the next? Failure. This doesn't compile. Oh yeah, because I of course need to pass it down so that the text that we assign here we pass in, but this one is nullable. So we also should make this one nullable. If it is null, then we should return -1. -1 could indicate that it's null. Not sure if this is the best. -1 seems weird. But I guess get index of does a similar thing, does it? C# get index of. And you have string index of. Oops, that's. Yes. And returns -1 if the character string is not found. Yeah, so let's go here with -1. And again, source generator does not contribute because there is another exception. And now the copy 2 is failing. So we need to pass it into the destination array. The destination array has 17 characters. I guess this is taken from the length Okay. So we need to put in, we have the source text, the source index, destination index, and the count. So we can basically now copy a string to a character array. It's still like a nice method for that. Copy string to char array C#. Stack Overflow. We can create a char array. Okay. Well, we are here. We are on .NET Standard, so we don't have the. If we were on .NET Core 3 or something, we would have string.create. Okay, new string char array. So yeah, no, but we need to fill a char. We need to do it the other way. Fill a char array. There is copy too. Ah, string also has a copy too. Perhaps. Ooh, that's the very same signature. Seems to be a great indicator. So we can say string dot copy to. Ooh, is this internal? No. Ah, it's an instance method. So if it's not null, source is not null, then we say source dot copy to, and I think we can just, they are called the very same, so we basically route them through. Cool. So we should now be filling this buffer, the destination buffer, with the string. Okay, we expected one syntax tree, but actually have 5. Yeah, I think I know why this is. But I first want to see if this behaves as I expect. I never used, or it has been ages since I used this. So we have the destination buffer, which is all initialized with zeros. And here we now have it filled correctly with additional text. Okay, but what we do expect here is this basically only works, I think, if the source index is 0. We kind of, let's do a debug assert. We expect source index to be 0. And we expect destination index to be 0. And we expect count to be of length. Doesn't necessarily work with. Okay, the -1 may be an issue, but yeah, we do check if it is not null. So here we can do this assertion before we actually copy. Count should be length. Expected. Oops. Oops. Expected count to equal length, where the count is count and the length is length. Okay. Because I'm not entirely sure what the driver may be passing in. But yeah, okay, and we could also implement this. Perhaps I will add later on tests for these to do test and implement. And the encoding, okay, I'm not sure about the encoding. Perhaps we pass this down as well. Let's assume C# is UTF-8, right? So no, that's the thing. It depends. Okay. Well, since we're using in-memory strings, strings are UTF-8, right? We can assume, since we're doing in-memory here, we can basically assume UTF-16. 16. So let's assume UTF-16 unless default, and perhaps we make this passable as well. Since I think we actually could, the generator could create an encoding. When we go to the, where it is, the test generator, in the add source, we can pass a string. Okay, and the string per default uses, this is where I have the UTF-8 off. Okay, per default UTF-8. So we could make it UTF-8 per default. But since the generator user could have its own source text where they pass in their own, cannot navigate to, but we pass their own encoding, so perhaps we should enable this later on as well for an advanced scenario. An optional setting. Where is the ad hoc? Source text use per default. Okay. But this suffices for now. We should have a failing test, and we do, because we expected 5 sources. No, we expected 1 source, but actually 5. And I believe this is why we fail here. Yeah, we only inspect the source, not the sources. So we basically need to do what we did here. I will move this up. Oops. Okay. And we say, basically replace every context source that we have with sources. This cannot be null. So we can basically say input compilation count. We first assumed we can only create 1, but we can now have multiple. So we have the syntax trees count plus the sources count length. This is how many syntax trees we expect. Where else do we use source? But we will figure out the next failure when we want to test. And yeah, we expected 0, but actually had 4 down here. This is the generated trees. The generated trees should be the length of the sources that we combined. Okay. And we expect 1 more failure. Generated sources here, where we actually assert the generated sources. Yeah, this needs to be now A. Also the length. So this test fails because we expected 0 but had 4, but I only print out 3 of them. There is something wrong with the assertion here. Is it that one? Let's find out. Yes, it is. Why do we only have 3? Because it only prints out the let's debug. And we actually have a 4. Yes, we have the original. Oops. And we have 2. Let's go into the... There is a new numeral visualizer. Let's test that. And it doesn't work as I expected. Well, classically, let's expand it. And yeah, we have so the original one and the additional path. So why does it not put out this one? Does it not have a hint name? Ah, okay. I don't do it's there, but I miss one. Yeah, I combine those. I string join these, but I'm actually missing. But I have a new line. String join, yes, so it doesn't. Yeah. The formatting is wrong. It doesn't. I want to append to each string that and not string join them because that only inserts them between. I guess I could do a string builder. Let's do a different way. String builder. For each hint name, we append a line of, we actually append the separator and then we append the line, the actual hint name. And then we throw join sources.toString. Okay, this should give a clearer message. And perhaps let's jump to the test because then I can click here and we see that we have an unexpected number. We expected 0 but had 4 and formatting is still a little bit off. But okay, but at least I now see that we have those 4. So all are there, but the assertion is wrong because I guess I still assume the old logic where I only expect one generated source. So context source is null indeed. So here we need to use the sources just as well. Now we should have replaced all context.source. So it's sources.length. And now they should turn green. And they do not, because, oh yes, so the hint text, the expected and the actual hint name differ. We expected path1.g.cs, but actual path1.text.cs. So we didn't do this transformation in the test generator. Where we iterate through all additional texts. And yeah, we use the path as a input, but we want to get this without the file extension. So we say, let's have a hint name variable equals to, what's that, path dot get a file name without extension plus, let's do a private static private const default file extension .g.cs string, and let's append these. So we have, this is now our hint name. And this should render the test passing. Because I have hint name twice, don't I? Yes. Additional hint name. Or I just reused that variable. Yeah. Okay. Still not green because, ooh, yes. I expect it to be different. So the expected code is actually, yeah, get here the diff. So this is what we expected, / text, and what we actually have is, oh, the beginning and end comment, yeah. Which means we should, in the test, for these, let's make a private function, no, a local function, static string get expected additional text. We pass in the additional text and return a starting comment, ending comment, let's get rid of the slashes here. Okay, this needs to be an interpolated verbatim string. Yes. No. Yeah. And we call this for each of these. Okay. Now this may pass. And it still does not, because we have one additional new line at the end, like so. Oops. didn't mean to hit debug. But they pass now. Cool. So we now support additional texts as well, and also multiple input sources. And now it's almost 9 o'clock UTC. Perhaps what's the English word that I'm searching for? Overdraw a little bit. To start building the diagnostics. Okay, we're not gonna need these. What we want is for the inspection phase to also expect diagnostics. So not empty, but the ones that we actually expect. We do this to a certain degree already. So in this generator, we basically, for every class that we have, we create a diagnostic. And here we have like 2 classes, and we expect 2 diagnostics. But we also want to have the location. So what I drew here, if I fall back to the previous one, we want to enable this syntax. So we have opening brace, the pipe character number, some integer, colon, then follows code, and then we have another pipe and the closing brace. This is very similar, but it's actually the same as Microsoft.codeanalysis.testing. So I want to inherit that functionality. And I believe for that, and let's also enable it, we also want to have it here. So this is also a class. This will also create a diagnostic, but at location 1. And like this syntax, so this now basically marks everything between this syntax here marks the location. So in our additional sources, we need to check the sources for the locations and then match these locations, 0, 1, which is this 0 and this 1, with the diagnostic that we expect here. Okay. How would we do that? We should in here get the locations. First, we actually need a failing test. So how do we get a failing test? We do compare the diagnostics. And so far we only match if the ID is matching. Okay, so additionally, it's not null. Okay, so this is like if we have an ID and perhaps let's put this in one line, this should make it more obvious. And if we also have our expected diagnostic may also have a location. But we need to match this location with the source. This may be tricky. Location, each of our expected diagnostics. Somehow we need to get the location. And this location should now, is this equatable? It's not. Yes, okay, it is. It's not equatable, but they do overload the equality operator. If the location is not equal to the expected location of the expected of the actual diagnostic. Get location. Hold on. No, yes, this should be yes. Okay. And this may now fail already because this location does differ. And also, yeah, also we don't what's the word? Cleanse? No. But get rid of this markup syntax. So we need to purify, what's the word? Our input string, our sources. Which we could do in here. So we could have a method, not sure yet, process markup text, process markup. We pass in the sources that we have, and we expect again let's make it a value tuple of source and location. But let's use, yeah, we have an array, yeah, that should be fine. This is a private method, static combination of text, string source and location, process markup, and we put in our array of sources. Okay, so we have for each source we guess we need a new string builder. Processed source or not clear. What's the word? Validate. Trimmed. Sanitized. Source. Where we basically need to, for each, not sure if this will be the well, we can make this algorithm more efficient later on, but we basically go through, if we do a for each on, now we guess we need a for loop for the index source dot value dot source dot length. This maybe null we care about null later on, and we will basically have a look at this pattern. Do I have the string somewhere? Yes, here. We basically must look for this pattern. So if we always start with that. If the source on position I is opening brace, and if the source on position I plus 1, okay, I also need to check if there is such a position, is this, and if the position I plus 2 is a number symbol equals to number symbol, then we have like an opening match found. Now we're in the open area, which means that the next character, the next set of characters may now be numbers. So we can get the position of the column if, how do we can check the source index of, can we also pass like a start index? We can pass in a start index that we find, yes. Our start index would be I plus 3. And we want to find a column. And if we find that, which means if this is our index of column is not -1, oh yes, missing a semicolon here. If this is not -1, then we found some, and we can actually get the, perhaps we should do something with value tuple, with a span of char to make this faster, but let's optimize it later. How do we get that? We can get the substring of start index and length. So our start index would be not I, but it's actually what comes after the, oops, I should have not removed these. What comes after the, no, what comes after the number, which is, or the hash symbol, which is I plus 2. And the length is now the index of the column minus I plus 3. Does this make sense? Not sure. Let's find out. And this can also be passed with a, yes, we need to call the new string, so this should be a number. And we should now be able to try pass into an int 32. Try parse number. Okay, let's call this, yes, number, and this could be out int markup markup location. And if it passed successfully, now we have a location. Or now we have, no, yes, now we know the location. And we can connect that. And we also need to sanitize the string. So if we find that structure, we basically, let's actually say, if we find that structure, it opens. We will, for any character, how do we do this? So for any character that we find, we append the character to the new string, unless we are in this location. When we find this pattern, then we continue. Then we don't add it because we're now in this pattern of this markup syntax. And we okay, we'll roughly draw this out, but we also need the closing. So now we need to find, basically we are now open. Can we combine these actually? What we also need to test for is like if we, I think this is also possible, we have like multiple, we have like here, public class text. And I guess we should also be able to combine this and now have here, let's say another one, 6, and then close both. Or let's make this a method, public void. Then we have the braces. We could have something like this. And perhaps even another one where we have the parameter. This could be now a 7 int param. And then I need to close it again. Yeah. So this pattern should also work. We open, we open, we close, we open, we close, we close. Yeah. So we now have basically this. No, this is location 5. This is location 6, and this is location 7. Okay, so this needs to be a lot smarter. Can this be solved with regular expressions? Perhaps. I will later on optimize this algorithm. I just want to draw out the basic shape of it and support like this for now as a start, and then I flesh out the details of this algorithm of stream in more detail. Okay, so we now know the location. Int current location or current markup location. If this is negative, what does it return? If this is negative, is smaller than, is less than 0, we should throw invalid markup key into it, markup location. And per default we are -1. When we have one which is not negative, we assign that so we know where we currently are. I guess this needs to be a stack to enable this pattern. And then we go on. So this is when we open. If we are in the open mode, which means if the current markup location is not -1, then we search for the close. And the close consists of these two. So index I is the pipe, and index I plus 1 is the closing operator. Ensure, to do, ensure, or what's it called? Check for potential index out of bound errors. And if we find this, we can now close. And we also continue, because we don't want to, perhaps we search for the yes. We don't want to add it to the sanitized version, which basically can now, if this is, perhaps this is somewhat working already, if we return the tuple of, oh no, we need to add this to a, this is multiple sources, so this needs to collect the, return a collection of. So we need a list of these. So value tuple. Output. It has the length of at least, that's initially with the capacity of the input. And we now basically to array it. And every time for each element, for each loop, we add output.add the sanitized .toString, but also the hint name, which is in the source.hint name, because the hint name shouldn't change. Source.hint name, is it not? So value.hint name, yes. Okay, and then we need to, yeah, this needs to be a tuple. And then we clear, and this is, yes, we need to get the, hold on, that's the source and the location. We don't have the hint name here. Okay. So the source and the location. Now we need a location. What does a location consist of? This abstract, is there already an implementation of location? We have no implementation of location, so I guess we also need a ad hoc location. It's internal, it's sealed, derives from location. And we add that. But this ad hoc location has a kind. The location kind can be none, source file, metadata file, XML file, external file. Unspecified location, then given the position in the source file. Perhaps source file, not sure if this is the right thing, but let's go with that for now. Why is this not compiling? Location does not contain an argument that, location is it's internal. I cannot initialize location, I cannot derive from it. The constructor is internal, we cannot build our own location. Okay, we cannot derive it actually, we need our own thing. And perhaps this consists of a path. Yeah, because we create a location via location.create. There is location.create. Okay. This is how we create a location. Yeah, but we have a syntax tree. We don't really have a syntax tree here. the text span. I will grab these file path and is text span the entire thing? Let's see where this goes. Actually, no. What if I don't need this. I just say here, location to create. Yes, now I need to fill it correctly. And now for each location we need to know, well, the file path could be the source.hint name. Okay. Now we need text span and line span. Not sure if I get these right. For span in a file. There in the namespace code analysis.text. I go with default for now. And this needs to be a value tuple. Okay. Clear does not return anything. As it does, by the way. We discard it. Okay, okay. And we append each and every character here. So let's see what we get as an output here already. Cannot implicitly convert from, because this is an array and this is sanitized. No, actually with location. Sources with sanitized with location. And when we run this, what is our output actually? So our input, this may not cover every case, but it could be a good start. Yeah, this is the expected. This is the wrong, I'm passing in the wrong value here. Yeah, I need to do this. This is wrong here. Need to do this with the input. So yeah, from the compilation. Okay, okay, we do this in the create compilation. Because here we inspect the sources. Oh, I removed too much. I just grabbed this sanitized. Because in the compilation we here, yes. And here is what we need to sanitize. Which means we basically this will be the sources. Which is a enumerable of string. Do we now lose the... Yes, this has no path actually. Well, we could just generate one, just a mattock path. So this is just an enumerable of string. Let's make it an array. It's private, so it's cool to be an array, I guess. String array. And this is just a string here. And we can make, yeah, all the values be gone. It's just a string. We have no hint name, so let's for now use ad hoc source file number. Are we still within this? We are not. Int current file equals 0. We increment that and use that as a path .cs. Okay, and text file, text span. We need to fill these, but let's see what the output is here now. If we run this test. Oh. To array. Ah, the string may be null. Okay. Well, this will create a bunch of warnings, but we will fix them later. Now let's see where this goes. Let's have a look at the output. We have 3 files, but we don't remove we only remove like this opening brace. We don't remove the rest. Yeah. Okay. So we need to remove the entire thing. Perhaps we then advance the pointer. So if we find this pattern, we can actually advance by 2 additionals. So let's say plus equals 2. But also the length of this number that we find. If so if we find this one, we also need to advance by this markup location. I plus equals markup location. And since we've also, do we make an error? Do we access? Yeah, should be cool. But also here we advance also by 1 additional. Plus equals 1. Okay. Let's see what we get now. At least a sanitized string would be great for today's goal. And no, still not. So we advance too little. And we don't remove it here. Does this work as I expect it to work? We go through, we do not find this yet. When we find this pattern, we find the colon as well. The consonant number 17. So the number, okay, that's way too much. So the index of the colon is 17. We currently are at index 13, which means that the length should be. Oh, yes. I didn't. No, I see I plus 2. Yes, okay, I plus 2 is 15. The colon is 17. Which means. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. It actually counts at 0, so this is 13, 14, 15. The number is at 15. We have 15 here, that's good. And the length should be 1. But it's actually 7, yeah. So I'm doing this wrong. Yes, I need to subtract the 3 as well. And I believe now I subtract 1 too much. Because now the length is, well, 1, no, it actually fits. So we now have we are off by 1. We don't want the number. Yeah, so I plus 2 is the index of the number, but we actually want the next thing, which is the colon. So we start from the colon and go over the length of this. So this should now deliver the number 0 in that case. It does. The markup location is 0. And we advance by, this is wrong. This should be the length of this number, yeah. Number dot length, okay. And what's the output now? Looks better, but the colon is still there. That's interesting. So yeah, we don't have it here. We only have it for the classes. So the colon still needs to disappear. Which means that we are advancing 1 too little, because we advance by 1, 2, and the column 3. Yeah. And if we run this, this may now actually should get rid of all these warnings, because the string should now be valid, because it's now sanitized of the markup. If we did it correctly. Yeah, so that looks good. But we don't use the correct one. Okay, so for the input compilation, yeah, we pass the source, but that's wrong. We need to pass the sanitized source per Yeah, so we select the sanitized sources and pass these. But this now also has a source. Okay. Let's make this. Can we make this static? Yes, we can. No, yes, we can. No, we have the context. We cannot. So this test may turn green now. And it does. Okay. So we now sanitize the markup. Yeah, we definitely need more tests to account for errors in the markup. Perhaps we put it into a separate class. This is sanitation. We put this, move to separate testable type. And we need to test for check invalid markup, syntax, and throw exception if invalid. But also allow nested markups, such as this one here. Okay. And for the location, perhaps we can get a brief hold of the location. So the text span has a start and a length, and this line position span has a line position start and an end, where the line position consists of a line and a character. Is the text span the entire thing and the line position now the, I would believe so, part of it? So the text span not sure if this is 100% correct, but I start with it. Text span should be this, and the length of the source, which is the sanitized toString. Let's grab this one. This would be the sanitized code. String sanitized code equals to sanitized toString. Let's then immediately clear it, so that's together, and we say sanitized code dot length, and the line position span consists of a start and an end. Where the start, so this is not a, so no, this is not a diagnostic. Yes. Okay, this is actually, we need to do this per, there may be one diagnostic per file actually. I guess we then have a collection of starts and ends. Let's do a list of these. Locations. And per closing, we add start and end. and that consists of a line and a character. So do we know in which line we are? I guess we can. We also need to support multiple lines here. But for now we can say int line number equals 0, int character count equals 0. I think it starts with 0. So we have the start and the end. We have the end here. The start we set when we know here, when we get the location, we know this is our start, and the start is the line number. We need to increment the line number every time we find a character. If the source on position I equals to environment.newline. I hope is this a string? Okay, okay, we. Okay, this would be super inefficient, but let's substring this with a substring of I. Since we create here, we allocate here every time a new span. This is very bad. String, this is very bad, but we will fix this later. And if this starts with environment new line, I guess this also gets a string comparison.ordinal. And if it does, we have a new line number. Then we reset the character count to 0. Otherwise, we increment the character count. But we should increment the character count at the end of each loop, or when we continue. Or let's start with -1, and then we can increment the character count and set it to -1 here as well. Okay. And when we start, we have our line number and our character count, and the same for the end. And then we should add start and end, which then means that we have locations, and for each location oh no, hold on, this is one file. Yes, and one file may have multiple diagnostic locations. But the location also holds the markup key. So perhaps we want to do here a custom location. Should be internal. Which receives markup key and a location. Now let's make these properties. Get only, yes. So the output consists of a collection of ad hoc locations. And here we now say, yeah, we create a location. Oops, that's one too many. So, but for each location, select goes to new ad hoc location, where we pass in the key and this location here, but we don't have the key anymore, do we? We keep the markup key in here. Yeah, current markup location. Can we use the, when do we reset that? Okay, we also need to add this to the locations, so that's also a markup key. Markup location. And we have here the current markup location and the start and the end. Okay. And that's our end. Then we have a lot of ends and starts. So for each location, we need a new line span. New line span that we get from the location. So we have location.markup key, markup location, and why does this not compile? Cannot convert from string to markup location is an integer, isn't it? Also, we need to await it. Yeah, that's hefty. I will refactor this later on. To array this one. And for the line position span, we need a start and an end, which is location.start and location.end. Let's see how this looks like. And the output is to array, but this has not changed because if we turn ad hoc location, yeah. Which is an array. Okay, this is not the best code. This definitely needs refactoring, but it should be a good start. It's not yet. Ad hoc location collection. Let's see what we get. We have a public class, sets a sanitized string, that looks good. We have one location, an ad hoc location, which consists of the markup key 0 and the external file location position. Is this position 1, 14? No, I think this is line number 1, 14th character. Does this fit? We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. And the class is what we have as a text between this markup span. Okay, so the second one should look similar because that's also the class. Public class 2 should also have like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. At index 15, I hit escape one too many times. And if we look at the locations, there is now actually 2 locations. Because why do we have 2 locations? Because I don't clear this. I have the previous one with the 0, this should go away. And okay, we definitely need, this should have separate tests. This should be separate method, separate tests. This is too much. And the second one is in file 1. Should actually be 2. Okay, something is wrong with the naming here. And we have 138, which should also be 14. It's doing something wrong here. And the third one should have actually no locations, but it still has the same 2 locations, which means that we, after here, we must clear this collection and the current file counter here is, because we actually to array this rather immediately, so they should be using the correct current file. We to array that immediately. So this should evaluate quickly. Not, what's the word term? Not quickly, but eagerly. So you do have the closure, which the current file, it encapsulates the closure, encapsulates the current file here. And this does evaluate immediately, and the current file is 0. That's cool. Maybe I just looked wrong. Okay. Let's have a look at what the output is. So the last one, since the last one is the struct, the analyzer that we have in place does not add a location for the struct, so location should be empty. It is, that's good. The first one should have 1 location on source file 0, markup key 0, yes. And the second one should have markup 1 and file 1, and it does 2. But it has 38, which I believe is wrong, because this should also be at position 14, since we have here 14, should be the 14th character. Is it? Because it says 0, 1, 2, 3, 4. No, it's actually column that basically starts at 1, doesn't it? If I have like here, that's character 1, yes. Or should it be 0? Not sure if this should start with 1 or 0. I need to look that up. As well, to do line count starts with 0. To do character count starts with 0 question mark, 0 or 1. Yeah, so we should do this for each. We have the, let's Let's move this inline of this for loop. Every time we start, we have a new line number. We start with 0, new character counter to increase immediately. Every time we have a new line. Does this work? As expected. Do we ever enter this? We never enter this. But that's because we don't have a new line. If we go to the test and introduce a new line here, let's see if we hit that. Yes, we do. It's super inefficient, but it works for now. And yeah, here we now also have 14. Okay, I guess this is good for now, since we already overdrew almost an hour. Okay, so the diagnostic thing is a little bit more complex than I thought, but I guess we're on a good path. I will do a couple of to-dos, move this into a separate file or a separate type, clean this up, have tests for that, what we built here. Basically, I guess start it again, build it again with the same functionality, but have it more formally tested. And we need, what else do we need in order to check for our locations? Then we can actually map these locations that we get here to the expected diagnostics. So what we add here, the 0, we can then map this 0 to a, for the diagnostics, map these to the to the locations that we actually retrieve. So we have then location 0, which should be in that file with that ID and so on. And this should then conclude the diagnostics, because we definitely need this diagnostic. It should be definitely a separate type, because we need this diagnostic extraction later on for like every, not for every analyzer, but for definitely for diagnostic analyzers and diagnostic suppressors anyway. But also for incremental generators. We don't need it for refactorings, but everybody else, every other component needs it. All right. And yeah, so for the next time, we will continue. This will be then session 4. Start session 4 with finishing the diagnostics. And then we are almost done, actually. Then we only have 2 smaller steps left. We also need the compilation. Let's see, where do we have it? We need, okay, we take care of the parse options. We take care of, we don't take care of the analyzer options yet, and of the metadata references neither. So those are the last 2 steps. And I guess this then concludes the incremental generator. To do, what was that, analyzer config options and the metadata. And this will be all for session 4. All right. Reusable for diagnostic analyzers, diagnostic suppressors, and source generators. Those are the Roslyn 3.8 version of source generation. Cool. So let's jump back to the discussion. I haven't put this into the chat. I will do so now. We followed up on session 2. We continued implementing the incremental generators. we enabled memorization optionally and asserted that the memorization doesn't only calls into the generation at one single time. Then we asserted the path, the hint name, and we started with diagnostics. Okay, this is not finished yet, so we will continue. I will add the agenda, basically the to-dos that we wrote afterwards. And yeah, so we may be finishing the I incremental generators next time already. If not, then we just have a couple of finishing touches left for session 5, where we then eventually, session 5, can then release the package. I will add this to the planned agenda. And yeah, all the links that we have explored through this session I will add to here. So this should be some complete resources compilation. And with that, I want to thank you very much for staying a while and listening. I never have the end screen ready. Now I do. Thank you and goodbye.